Welcome to Alchemy Video, or Reality Creative Video, whatever you want to call it. We talk about alchemy more these days than anything else. Today, I want to cover a couple things. I've been working on plasma arc. Now, first is my tops. Now, this is the normal top that I use, and you'll see it has this little plastic part here. Now, when you're cooking with the plasma arc, and then there's this glass part here as well. The glass is to help isolate the wires so they don't conduct between each other and cancel out the arc. But the glass also helps prevent the intense heat of the hot wires from melting the plastic. The problem I have with this top is this plastic piece where I create this angle here. Sits in the water, and there's no glass in here, so the wire heats up and starts to melt. Wherever it's leaning against in here starts to melt, and these pieces heat up, especially when you're cooking for 40 minutes. You'll be at the boiling point of water in here, and so these things heat up, and even though that they're made of ABS plastic, they still start to deform a little bit. And what I like to do, I wanted to keep the plastic out of the water entirely. Unfortunately, that negated being able to use my modular unscrew, these things unscrew and put whatever top on you want. But, necessity means you have to change things. So I made this top. And this top has permanent glass tubes embedded in it, and only the glass tubes sit in the water. So I don't get any melting. I don't get any plastic in the water. The plasma arc is completely isolated. There's nothing else in the water but the metal and the plasma arc. And this is working out pretty good for so far. So I'm going to continue to test this top and stuff. Now the other thing that I've been playing around with is my chemist been talking about electron theory. There's something a lot of things have been happening in the comments section. I've been on various stuff that I like to talk about. I don't know if I'll have time to talk about it all in this show, but let's see what I can fit in, because I know you've been deprived of my shows for a few weeks now. So one of the things is called Ormus, and it's an alternative to colloidals. Basically, it's like a colloidal. It's a perfect atom of the metal that you're trying to consume. And there are various ways to create Ormus, and to be perfectly honest, I'm not so sure about it. I don't think would be as good as colloidals, and creating it seems very. I don't want to talk about Ormus, but what I want to talk about is the principle in Ormus, which led me to researching Ormus, and how these selective atoms are pulled apart from the so you have a whole clump of like silver atoms, and with Ormus you pull out specific silver atoms that are all similar to each other. One of the similarities in this of these special atoms, separating the atoms, is electron spin. They have the same electron spin. It got me into thinking, with doing research on electrons and atoms and things like that. And so you can have the electrons which orbit around the atom. You can spin, and when we're talking about like planetary orbits, okay? Electrons don't actually orbit around the atom, like you see in they show the atom going around, like the electron going around like this. They don't actually do this, all right? That might be for another show. And they also have a spin on them. And they like a planet, they spin as they're going around the outside of the electron. But they don't actually orbit. And they don't actually spin. I know quantum mechanics is weird. So we have this electron which doesn't actually orbit around the atom, and we have this electron that has a spin that doesn't actually spin. But these electrons behave like that's what they're doing. But that's not exactly what they're doing. And we're not talking about that either today either. There's a video I watched on it which is really, really cool, and I'll link to the description on it. It's about a 20-minute video. The guy talks about electron spin and what it is and a few other things. Science video. For those sciencey guys that you want to talk about it. But anyway, it got me to thinking about this electron spin. The idea of getting all of the electrons to spin in the same direction, which don't apparently really spin. So I did research and found that it is a thing. You can subject stuff to things to a high concentration magnetic field, and it will cause the electrons to all spin in the same direction. And what's more so is that once you got them all going in the same direction, the spin that doesn't actually spin, they will stay that way. Now it has to be the metal we're talking about, or the in this case colloidals, we're talking about the metal. I mean, you can magnetize water, but water will not stay magnetized. It will demagnetize within 48 hours. So that doesn't help us with our colloidals and long-term, thing. If there's even an advantage to magnetism and magnetized water with colloidals and drinking it. I don't even know if there's an advantage to having all of the electrons lined up in the same, spinning in the same direction that would help with colloidals. But in theory and in practice, what the scientific community seems to think is that when these electrons are all lined up together, their tiny little charges don't fight each other. If one's going this way and one's going that way, you got a little bit of a cancellation effect going on there, especially when they pop up close to each other as they're orbiting around the electron, which they don't actually orbit. So if you got them all spinning in the same direction, then these little charges kind of add to each other. And in the case of colloidals, I'm thinking that maybe it would increase the solubility of the colloidal in the body. Not that we don't already have a high concentration of solubility with colloidals in the body, but hey, if you can make something better, why not? So this is what I'm just working on it. This is a beaker which has magnets, super magnets on the side, and as I create you could do this low voltage DC or high voltage, plasma arc. As the water is spinning, you do have to have the water spinning to make this work. All right, it goes by the magnets, and this forces, in theory, all of the electrons to align in the same direction. Now, I was hoping in the microscope, took some pictures in the microscope of what we call it magnetized colloidals and unmagnetized colloidals, and I don't see a difference. I was hoping I would see some subtle difference in how, the particles align, the particles were aligning, but there doesn't seem to be any difference whatsoever there. So it would have been nice to have like a verification that we did actually change the state of the electrons. There's no way of knowing without an electron microscope. But it's not going to hurt, it's not going to hurt to have the magnets on the side here while I'm creating the colloidals, and, do test batches and see if people seem to feel that these colloidals are working better than previous colloidals. And only time is going to tell with that stuff, because I don't have an electron microscope to look at the state of these things to see if they really are that way. And of course, people have to consume the colloidals in order to say, hey, wait a minute, yeah, this is better. But I don't think it's actually going to hurt, and I'm just mentioning it to you guys. You're making your own colloidals. If you might want to do something like this, put magnets on the side as you're making the colloidals. It certainly doesn't inhibit the process at all. They're all on the outside of the beaker, not on the inside, so not going to make the colloidals worse, that's for sure. If anything, it might make them better. So that's my latest thing I'm working on, and down the road, as I get results or feedback from this using magnetism to enhance my colloidals, I will certainly update everybody on that. And I'm sure I'll have more interesting videos for you in the future. So I thank you everybody for visiting my channel and watching my videos. I'm Hermes, and this is Alchemy, and I will talk to you again soon.